Hello friends, welcome to my channel. This is Fluid Mechanics Part 9 Isro question paper from 2006 to 2016. The transition Reynolds number for flow over a flat plate is 5 into 10 to the power 5. What is the distance from the leading edge at which transition will occur for flow of water with a uniform velocity of 1 meter per second? For water, kinematic viscosity is given 0.86 into 10 to the power minus 6 meter square per second. Data given are R equal to 5 into 10 to the power 5. Then distance from leading edge, x we have to calculate. Uniform velocity v equal to 1 meter per second. Kinematic viscosity is 0.86 into 10 to the power minus 6 or 0.86 divided by 10 to the power 6 meter square per second. So we know R equal to V into X by kinematic viscosity. So put all the values. 10 to the power 5 into V is 1, X we have to calculate. Here it's 0.86 divided by 10 to the power 6. So it's 10. So X equal to 5 into 0.86 divided by 10. It's 0.43 by 10. So 0.43 meter. From option, the distance from leading edge is a 0.43 meter. For a reciprocating water pump having cylinder dia D and crank radius R, with capital W is the weight of water lifted, the coefficient of discharge we have to calculate. Diameter is cylinder dia or bore dia is D and crank radius is R. W is the weight of the water lifted. CD we have to calculate coefficient of discharge. It's Q actual discharge by theoretical or ideal discharge, QT. Here in this case, weight lifted W equal to Q into specific weight, Q actual into specific weight rho g. So from here Q actual in terms of W will get W by rho g. This is equation 1. And theoretical discharge is QT. It's volume flow rate, area into length of stroke. So area is 5 by 4 bore dia square into length of stroke is 2 into crank radius. So Q2H we got pi by 2 D square into R, pi by 2 D square into R. This is equation 2. So from equation 1 and 2, the CD value we have to calculate. CD equal to Q actual by QTH. W by rho G divided by pi by 2 d square R. So finally CD equal to 2W pi d square R into specific weight is rho G. So in this question specific weight is given R into specific weight. We know rho G equal to gamma. So from option 2W by specific weight into pi d square R. B is our answer. Both free vortex and forced vortex can be expressed mathematically in terms of tangential velocity v at the corresponding radius. Choose the correct combination. Free vortex and forced vortex. We know in case of free vortex, here conservation of angular momentum we are using. Conservation of angular momentum. It's M1 V1 R1 equal to M2 V2 R2. M is same. So V1 R1 equal to V2 R2. So V into R is constant in case of free vortex, and in case of forced vortex angular velocity omega is constant. Omega is constant, and we know that V equal to R omega. So V by R equal to omega equal to constant. So forced vortex V by R equal to constant. From option V into R is constant, and in case of forced vortex V by R is constant. D is our option. A bucket of water is hanging from a spring balance. An iron piece is suspended into water without touching sides of bucket from another support. The spring balance reading will be how much? It will remain same. First I will draw the diagram. This is iron piece. When it will pour into water, then weight of fluid displaced equal to Fv, and Fv plus tension of the string equal to weight of the iron piece. So first case W1 is the weight of water inside that bucket. It's downward, direction is downward, and in second case W2 is balanced by Fv plus T. So net downward force W2 is unchanged. So here spring balance reading will unchanged or remain same. A is our answer. A single stage impulse turbine with a diameter of 120 cm runs at 3000 rpm. If the blade speed ratio is 0.42, then the inlet velocity of steam will be how much? First we will write what are the data given. Diameter D equal to 120 centimeter or 1.2 meter. N is the RPM, it's 3000 RPM. Blade speed ratio or rho is small u by V, 0.42. Inlet velocity V we have to calculate. So u we have to calculate. Small u is 5 dn by 60. Pi into 1.2 into n is 3000 by 60. So it's 50. 50 into 1.2, it's 60. 60 into pi. 60 into 3.14 will get 188.4 meter per second. From here also we can omit two options. We know blade speed ratio is 0.42, so V is greater than U. U already we got 188.4, so V is greater than 188.4. So A is not possible, B also not possible. Then we have to go for C and D. Rho equal to U by V, we have to calculate V. V equal to 188.4 divided by rho is 0.42. It's nearly 190 into 100 by 40. So 19 by 4 is, it will come around 4.7 into 100, 470 meter per second. So approximately 450 meter per second. C is our answer. In fluid masonry, the relationship between saturation temperature and pressure decides the process of A. Flow separation, B. cavitation, C. turbulent mixing, D. water hammer. A relationship between saturation temperature and pressure. It divides process of cavitation. Cavitation process, it decides. So B is our answer. The Moody diagram is shown in figure. The friction factor for turbulent flow in a smooth pipe. Turbulent flow in a smooth pipe. Frictional factor for turbulent flow we know it's 0.316 divided by Re to the power 1 by 4, and frictional factor is inversely proportional to Re to the power 1 by 4, and F is proportional to D to the power 1 by 4. These three things we have to remember. These are important. And in this figure, it's D to the power 1 by 4. So this one, E is our the required curve. This is Re, Reynolds number. So from option C is our answer. Thank you friends. Thank you for watching my video. If you like my video, then subscribe it. Thank you.